Max case study. Purpose of inverse Laplace transform. In mathematics, the inverse Laplace transform of a function is the piecewise continuous and exponentially restricted real function which has the property L set bracket f close set bracket of 8 is equal to L set bracket f or bracket of t set close bracket of s equal to capital F of s, where L denotes the Laplace transform. It can be proven that if a function has the inverse Laplace transform ft, then f of t is uniquely determined considering function which differ from each other only on a point set having legacy measure 0 as the same. This result was first proven by mathematics Lurch in 1903 and is known as Lurch's theorem. The Laplace transform and inverse Laplace transform together have a properties that make them useful for analyzing linear dynamical system. Next, Mellins inverse formula, an integral formula for the inverse Laplace transform called the Mellins inverse formula. The Brovich integral for the Fourier Merlin integral is given by the line integral, where the integration is done along with the vertical line Re of s is equal to y in the complex planes that y is greater than the real part of the singularities of f of s and f of s is bounded on the line. For example, if counterpath in the region of convergence, if all singularities are in the left half plane or f of s is an entire function, then y can be set to 0 and the above inverse integration formula becomes identical to inverse Fourier transform. In practice, compounding the complex integral can be done by using the Cauchy residue theorem. Post inversion theorem. In this post inversion formula or Laplace transform named after email post is a simple looking but usually impractical formula for evaluating an inverse Laplace transform. The statement of the formula is as follows: let f of t become a continuous function on the interval from 0 to infinity of a exponential order for some real number b, then for all s greater than b, the Laplace transform for f of t exists and is infinitively differentiable with respect to s. Furthermore, if f of s is Laplace transform of f of t, then the inverse Laplace transform of f of s is given by the given equation.